All right, hello everyone. So today we're going to solve a nonlinear inequality. 3 divided by quantity x minus 1 is less than 5. So it is often the case, and when I do these, that I like to make one side equal to 0. So I'm going to subtract 5 from both sides. And the reason I'm doing that is because when you're working with an inequality, a nonlinear inequality, you're comparing your result to a number, and I find that comparing it to 0 is a lot easier in terms of positive or negative than a number like 5. So that's why I'm doing this. And what I'm going to do with this expression is I'm going to get a common denominator. So that's your next step, is you move everything over to one side, you get a common denominator. In this case, it's x minus 1. And where I have the 5, I'm going to multiply both the top and the bottom by x minus 1. And I'm going to put that all over x minus 1. And this would come out to be 3 minus 5x plus 5 over x minus 1 is less than 0, or 8 minus 5x over x minus 1 is less than 0. Now, the next thing I'm going to do is as follows. I'm going to find out where the numerator and denominator are equal to 0. So 8 minus 5x equals 0, and x minus 1 equals 0. So you would have 1, and you would have 8/5 for x. Now, at these two places, your inequality is either 0 or it's undefined. And any other number that you pick other than these two, it's going to make your inequality positive or negative. Okay, so that's the importance of doing this step. Now, we need to actually find those numbers that make this expression less than 0, because that's what we're asking today. What numbers do I plug in into the expression 8 minus 5x divided by the quantity x minus 1? That would give me something less than 0. Well, there's a way to gather that information and organize it. So I set up a line interval with 1 and 8/5. You don't need to do this, but I like to just organize things out. And you have this like natural division that's been made in 3 intervals. Values that are less than 1, values that are between 1 and 8/5, and values greater than 8/5. Okay. And what my little chart here is going to do is I'm going to take each of the terms in our expression, and in a way they're factors, and I'm going to see what the sign of each of these terms is. So I'm going to check what the sign of 8 minus 5x, and check what the sign of x minus 1 is, and then total 8 minus 5x over x minus 1 in each of these intervals. So the way this is done is you pick something that's less than 1. So for example, if you pick 0, so I'm going to start with that interval, x is less than 1, and I'm going to plug that into 8 minus 5x, x minus 1, and then the result. And if you pick something that's less than 1, like 0, you're going to get something positive. If you plug, again, that same value, use 0 into x minus 1, you're going to get something that's negative. So positive divided by negative, that's what I'm looking at for this last part over here. That's going to be negative. And what I picked 0, you could pick anything as long as less than 1. The result will hold for any value that's less than 1. So some people worry, oh, well, what if it's, you pick 0 for 1 and then another, does the expression hold? Yes, does the inequality hold that you have you have positive and negatives? Yes, it does. There's a more rigorous way to prove that, for example, 8 minus 5x is positive for all x greater than 1. But we're not going to do that here. But it would work out in a similar manner than I'm working with here. So for the next interval, from x is greater than 1, less than 8/5, you pick a number between 1 and 8/5. So this is a little harder because that's 1 and 3/5. So for example, 1.5. So if you did that, you would get positive here still. X minus 1 would be positive, and positive over positive is positive. Now, if you pick something greater than 8/5, you would get negative here, positive here, and then total you get something negative. So your solution to this inequality would be where we wanted negatives would be here and here, because again, we turned our original inequality here, sorry, up here, subtracted the 5, and now we were looking at this, and all of this was equivalent to saying that right there. So it's still less than 0, it's just that we moved the equation around to solve. And what's our solution going to be? Well, it's all the stuff that's less than 1 or greater than 8/5, which is negative infinity to 1, not including, union 8/5 to infinity, not including, right? We're not including, we don't put a bracket and we put a parentheses because we're not including the number in the solution, and we don't have an infinity here because bracket on infinity, because infinity is not a number, it's a concept, and that would be your solution. And in a line interval, here's 1, here's 8/5. So yeah, I mean, I know I can just go up to the one I just created, but I want to use this one, I want to create a separate one for this purpose. So our solution would be everything here and everything over there, okay? All right, well, I hope this helps. Thank you for your time.